Hey guys, welcome back. When it comes to measuring current and voltage at the same time, you need at least two multimeters to do so. Yes, everyone should have at least two of them, but what if you need to measure more, like measuring current and voltage from another source? Well then, this project comes in handy. It's suitable for beginners and it's really cheap and easy to make. If you use the Banggood links from down below, I linked a few parts that you can use to build a similar one. Actually, the amperage, the ammeter and voltmeter is the same, just a slightly different model. Measures just as this one from 0 to 100 volts, from 0 to 10 amps, and you get slightly different binding posts and a battery box with a switch that is already included. And the $11 I stated, I have included $5 for a piece of acrylic, because I'm going to bend a piece of acrylic in like a triangular shape. For then I can install the amp and voltmeter at a slight angle so it's easier to read. So this is how everything gets set up. We have the volt and ammeter over here. It has a small connector. In my version, only two small connectors, black and red for plus and minus. I will connect a switch between plus ingoing and the battery block. And the ground goes in as black. I have 9 volt. And my version has this 3-pin connector. It measures amperage between going through black and blue. Black is the ingoing, blue is outgoing, and the red cable is the voltage sense. And it can only measure voltage with a potential difference between red and black cable. So we have ingoing plus that gets connected with the red cable. It goes to the plus out, and for these I do have these two red banana connectors, whatever, I forgot how they are called. And I have minus ingoing directly into the black cable, and we do have the minus out, which is the blue cable. And within a bit different looking schematic, because I was way too fast throwing the other one away, a few further explanations. So I'm using a 9 volt block battery, but you can actually supply it from 4.5 volt DC to 30 volt DC. And if you have it set up in this way, you can measure only voltage if you connect plus in and minus in. The unit itself has, by the way, 100 volt DC and 10 amp. It can measure maximum ratings. And there's also another way to connect it different, so you don't need a 9 volt block battery and its switches either way optional. That would be to connect the positive supply to the positive in, the negative supply to the negative in. But then you could only measure between 4.5 volt DC to 30 volt DC. And that's the reason how, why, not how, but why I have it set up like this. So if you buy one of these modules, it's really likely that yours has a different color coding, but that's not a big deal. Most of the time they come with a big 2-pin connector for the shunt, so this is easy to identify. If you have a third cable on the 3-pin connector and you're not sure which one is the shunt and which one the current sense, then it's just easy to use a multimeter on continuity, and I just have to connect the right cables together to get a signal, and you know which is the shunt because they are isolated from the voltage sense wire. So if I connect over here, there's no signal, only if I connect through the shunt. And If you have 3 thin cables, it's really likely that the yellow one is the sense cable, yellow-green, because they typically use black and red for the voltage supply. For this project I'm going to use this. I used a piece of acrylic, bent it into shape in the triangular form I already told you about. I made a few cutouts and drill a few holes, and that is where the module will be seated in. And this is how I bent the acrylic. It's really easy, and you don't have to use a dedicated heat gun just as I did. You can also use a hairdryer. It just takes a bit longer. Now that you saw how I did this bend, we can go ahead and assemble it. I figured that showing me how to drill holes and make this cutout is not really interesting, so I was not filming it. But now let's go ahead and connect everything together. So I do have this 9-volt block battery holder, and I drilled these holes because I do have these pins over here that I did not want to remove. Maybe I'm going to use this in a later project, so I'm just going to use this foam double-sided tape and glue it into place. And over here I'm going to attach the switch, which is quite difficult to do. And now let's connect the battery holder to the switch and the supply connector. Okay, now this is done, and now I am going to install all the binding posts. so I can start wiring them. And now that the binding posts are installed, I'm going to solder the 3-pin connector to the binding posts and also a piece of spare wire. I'm going to short out the upper 2 plus rails. I'm attaching a sense wire over here. I'm attaching the income wire on this side, so this is my income side, this is my outgoing side, and the blue cable gets soldered in here. Okay, I tried soldering to these connectors, but that is just impossible. What I'm now going to do is I'm just removing insulation far enough so I can wrap around the cables and then tighten down the second nut on top, and hopefully this should just be fine. Problem is I don't have any of the fork type connectors or similar that could just grab onto this size of a thread. So this should just be fine. I have a lot of exposed cable, and yes, solder is not a good conductor. Well, it has some resistance to it, but that should be just fine even for 10 amps. So no problem there. Okay, all the cables are wired correctly, and next thing to do is to install the module, the battery, and test everything. A few zip ties are a good idea. Let's see how we can neaten up everything a bit. Think like that. Okay, that looks much better. And install the battery. Just like that, even though it's a bit weird. Okay, that's okay. So, and yes, by the way, I slipped a few times here and there, and I might replace the acrylic, but I don't have another piece. But this is it. This is how it looks, and I think this looks quite nice. And this is obviously not meant for measuring high voltages, and 100 volts isn't high enough so you get really hurt. And it's in standalone mode. You can carry it around and measure voltage or amperage. Before ending this video, I'm obviously going to test the unit. I have my lab-inch power supply hooked up to the input side of the module, and on the output side I connected this LED light strip, and this is unfortunately the only load that is available to me right now. I would like to show you a motor or something else with a higher amperage, but this should be just fine to see if the unit works. So let's turn on the unit and turn on the power supply, and I will now rise the voltage. Okay, 0.01 amps is not displayed and the LEDs do light up, but at 9 volts 170 milliamps is displayed correctly. The voltage is slightly off. And now let's go to 12 volts. and the voltage is slightly off, same as the amperage, but that's totally fine. And by the way, I'm not going to connect any multimeter in here because these measurements over here, they are the same with my multimeter, so this is just fine. And as you can see, it works without any problem, 900 milliamps, and well, that's pretty much it. Thanks for watching, guys. I hope you liked this small little project. This is not only a project that is suitable for beginners, but also for people that are more advanced in electronics, and you can obviously change the maximum ratings depending on the module you buy. But this is also really cheap because this unit, as it is, only costs $11. So yeah, thanks for watching, and I hope to see you next time. Bye!